Okay, this video will be about how to make a tube that's adjustable so that a car can turn, and also that lets a wheel spin very freely. You notice that no part of the wheel is touching the car. If that were to happen, when friction is applied to the edge of the wheel, the distance that force is applied is much greater for every turn of the wheel than if it's at the center. So that means that any friction force applied to the edge does much more work than the friction that's applied to the center. So what makes a wheel like this efficient is that where most of the friction is from the weight of the car pressing against the stick, every time the wheel turns, this only goes about 3 times pi millimeters, so about 10 millimeters or 1 centimeter for every turn of the wheel, while the car will go a very long way every time the wheel turns. So that's what makes the wheel and axle so efficient, is very little work is done by the friction of the axle pressing against the car for a very long distance of the car's travel. So we're going to make a tube like this, and to start we'll need a piece of paper, a ruler, a pencil, and at least the start of our car. So I'm going to take this off so I can show you how we measure it. So the first thing we're going to do is we want this part to be about 1 centimeter wider than the car so that it keeps the wheel away from the edge of the car. So the only part that will actually be making direct contact with the wheel is this part, very close to the centimeter, very close to the center of the wheel. So the way we can do this is just measure your car, see how wide it is. In my case, it's about 67 millimeters. Whatever distance you get, you're going to add 2. So if you measured 70 millimeters, you would add 2 centimeters, which would be 90 millimeters. Or if we do it in centimeters, I guess you could just say this is 7 centimeters wide. You add 2 centimeters, and it's 9. But in my case, it's a little bit more narrow. But what I'm going to do is I'm going to add 2 centimeters to what I get. And I'm going to make a mark on the page. So this is the width of my car, and then 2 centimeters more. So I'm going to put a mark here, and then just so I can make a straight, a good rectangular shape, I'm going to take another measurement here, the width of my car plus 1 centimeter plus 2 centimeters. Now that I have those 2 marks, I'm going to draw a line through them. And then I'll check and make sure that I am indeed about 1 centimeter. My paper is about 1 centimeter wider than the car on each side. So that's what you're looking for. You could go as far as 1.5, but if you go too much longer, the car is wider than necessary. So once you have this shape, we're going to tear it or cut it down this line. But before we do, we want to make the inside as slippery as we can. So we're going to make a place for the axle to go. I'm going to make it from here to about here. So I'm going. The exact measurement here isn't that important, but I'm going about 1 centimeter from the edge, and then I want it to be 2 centimeters wide. So I'm making my mark from here to here. So the reason why I'm doing this is the form of carbon that's in the lead of a pencil is very slippery. So it can be used to reduce the amount of friction of this axle against the tube. So I'm going to just fill in that part with the material from the pencil lead, which is not lead but a form of carbon where it makes small sheets. Graphite is a really cool thing to look into, so I recommend looking it up. There's even a trick you can do with some tape and graphite to make single layers of graphite that are large, where the flakes are kind of large, called graphene. And that also has something to do with what makes this as slippery as it is. It's also one of the reasons why pencils are good for writing, is because they slip over the paper. So once I have a good layer of graphite dust there, I want to cut this rectangle out. I'm going to use the method of folding. If you want an even tear, it helps to make the fold in both directions so that weakens the part of the paper where we want the tear to go. So I'm going to try to tear this piece of paper into two parts. So I'm trying to weaken this part right where this crease is. I made it a little bit past the line, but that's okay. As long as it's about a centimeter wider on each side, it will work. I can make this crease a little weaker still by just scraping a piece of metal over, in this case the edge of the scissors. Again, I'll do that on both sides, so that will make the crease very easy to tear apart, which will make it less likely that it will tear where I don't want it to tear. So now this should come apart. Okay, that gives me a nice rectangle. Now, we made some of these before, where we started rolling right at the edge. This time we're not going to do that. I want this stick to have a pocket, sit in a pocket of graphite. So this graphite here, I want to be the center of the tube. So instead of folding at the edge, I'm going to put the stick right in the center of this graphite. And I should also have a piece of tape ready. When we finish rolling this tube, it's going to be a little bit looser because I need the stick to be able to rotate freely. So I'm not going to put the tape on exactly when it's rolled. After I roll it, I'm going to let it slip about half a centimeter. So it's going to slip about this much, which will make the inside a little bit larger so that it's easy for the stick to roll around. So I'm going to roll it up pretty much like we made the other two, except I'm going to keep the stick in the center of this graphite. Moving at an angle, I want it to be straight, so unwrapping it. Just trying to make sure I roll it so that it doesn't go off to this side or that side. Essentially, I'm keeping this axis of the stick perpendicular to the edge, or parallel to this far edge. Okay, so at this point, the stick's actually a little bit loose, but I want it to have a little more freedom, so I'm going to slip this piece of paper over about half a centimeter before taping it. So you can see how it's kind of a little bit loose here. And then I'm going to play with the stick until it gets wider. This might take some doing. Another trick that can also help is if you have some pencil leads from a mechanical pencil, you can put the pencil lead on the inside of the tube with the stick, and this will have two advantages. It can loosen up the inside of the paper, and it will also put more graphite powder in it to make it easier for the stick to roll around. Also, when you're trying to increase the center of the tube, you want to roll it so that it rolls in the same direction as this piece of paper. So, like if I want this center of the tube to be wider, I want to push it this way, towards in the same direction of that curl from the center. So the paper is curled this way, so I'm pushing the stick around in that same direction. And what I'm looking for is, you see how this paper spins very freely around the stick? That's what I'm looking for, because I want to keep the friction as low as possible. So once I have that, I'm going to apply 2 pieces of tape just to the ends, just so that this doesn't come apart. I want to be very careful though not to have any tape go right on this edge. Same thing, there shouldn't be any hot glue right on this edge, because that could make contact with the wheel and slow it down, increase the friction, which we don't want. We want to minimize the work done by the wheels rolling through the tube. Our goal with this car is to help it use the energy as efficiently as possible. So that could be energy from a rubber band or energy from a weight that's falling from the tower. So now that I have this, I'm going to attach it to my car. And I'm going to use rubber bands to attach it because I want it to be able to, let's say the car is going this way, I could adjust the wheels to compensate so that it goes straight. I'm also going to put this on the bottom so that since the car is going to be sitting on the wheels, that's going to have most of the force is going to be from the axle casing against the body of the car. If I put it this way, then most of the force would be on the rubber bands, which would make it less stable. So I'm going to attach it this way. I'll start by putting the rubber band around the tube. And then once it's around the tube, I'm just going to treat it like a rope, tying the tubes together. So I'm going to wrap it around this tube on one side and then on the other. And then repeat the process until it starts to get a little bit tense. I don't want the rubber band too tight because it could crush the tube and then the wheel won't spin freely. So once it's just a little bit tight, I'm going to close it off just by putting it around. I could put it either around this tube or that tube. So in this case, I put it around this tube. If you miss some of that, I'm going to repeat the process on the other side. So I'm going to start just by putting the rubber band around the tube like this. And then I'm going to wrap it around the other tube. And then over and back around. And welcome, we have help from a custodian. And no, it's all good. So once it gets tight, I'm going to just let it attach to that tube. You see, like instead of just wrapping it around, I'm going to, once I have the right amount of tightness, just a little bit tight, not too tight, I'm just going to slip it over the tube like that. And then adjust it, try to make it as straight as possible. Make sure the tube isn't crushed, so it's still free spinning. And that's it. The next step is going to be actually making our wheel. So in this case, this is our wheel. And you can see that it spins very freely and just spins for a while. So that's really all there is to it. Good luck.